Good morning, class. Today we are dealing with differentiation, a revision. Firstly, let's go into differentiation from first principle. Now, from what is written on the board, given that y equals to a function of x, meaning y equals to a particular equation of x, therefore, the differentiation of y with respect to x, which will give us the y dx, meaning the change in y with respect to change in x, implies the differentiation of the equation of x, which is defined as the function of x with respect to what? Change in x. That's where we have the y dx implies the f of x over the x. Let's now consider a situation where we have the change in x. Now, in that change in x, we say let the change in x be h. That's why I'm writing then change in x can be taken as h. So in just case, differentiation of function of x to the s can be taken as f of x plus h because there's the addition of change in x to the function of x. Meaning, we consider the addition of change in x to the function of equation of x, then we take away the function of x, which is the equation in terms of x, that is the equation of y, are limiting our x to 0. So we have of f of x plus h minus fx all over h, limiting our h to 0. Now, let's now take an example of this. Given that our y is said to be x squared minus 4, x squared minus 4. Now we want to differentiate x squared minus 4. To differentiate x squared minus 4, that means our y here, which is the function of x, that is f of x now, is x squared minus 4. Then from here, we can consider the addition of the change of an x there. Okay, meaning if I'm considering the addition of the change in x, that is the f of x over the x being the f of x plus h, this is square minus 4 all over a minus 4 here, then minus f of x itself all over h, where we will be limiting the value of h to 0. We'll be limiting the value of h to 0. So in this case now, what's the next thing to do? Let's now expand the fraction there. We expand that bracket where we'll be having x squared plus 2xh plus h squared. Then we have minus 4 there. Then minus our f of x, which is x squared minus 4 all over h. All over h. And in this case, remember, we are limiting our h to 0. We are limiting our h to 0. Now, to continue, I'm going to rub off this word. From there, we'll be collecting the like terms, or first of all, we open the bracket. So, where we have x squared plus 2xh minus, plus h squared minus 4. That minus x squared minus 4 will now become minus x squared plus 4 all over h, where we limit our h to 0. So from there, we now have the collection of these like terms as limiting our h to 0. We have x squared minus x squared plus 2xh plus h squared minus 4 plus 4 all over h. So from there, how we have this and this to nullify each other, this and this to nullify each other. So I will have 2xh plus h squared over h. And that will give me limiting h to 0. I have h into 2x plus h all over h. This will cancel this now. So from there, I will have limiting h. Remember that our differentiation of x with respect to changing, our differentiation of f of x with respect to what? Changing x is giving us this expression. So meaning we'll be having the f of x over the x, meaning our dy dx still gives us limiting h to 0. What do we have left? 2x plus h. Now remember, we are limiting our h to 0. So meaning our value of h will be taken as 0. So the f of x over the x, which is actually our dy dx, will be giving us 2x. That is solving from our first principle. Now to standard derivatives. Under this one, I'll be attaching a particular note to the video so that you can see the explanation of some of the things on standard derivative. But with that, I'll just explain one or two things. Under standard derivatives, if y is given as x raised to power n, therefore the y, the x, is given as n into x raised to power n minus 1. X raised to power n minus 1, or you can just take this away because it will still give me the same thing. So meaning with this, we can solve any other expression. And this is the basic function that gave birth to every other form of expression, just considering whatever form of expression you are given as the example, as the case may be. Now, I'll be going into some of the examples that we may be taking this expression to solve. Let me put this at the right hand corner here. Meaning if y is x raised to power n, then the y, the x, will be n into x raised to power n minus 1. All right, let's now take examples now. Example. First one, if our f of x is given to be 2x raised to power 7, how do I find my differentiation of f of x to dx, meaning my dy dx? Recall, I will have my n to come to the front. So my n in this case is 7. 7 to come to the front, to multiply my 2x. Then the power of x is taken to what? Reduced by 1. So I'll be having 7 minus 1 there. So here I'll be having 7 into 2 x raised to power 6. Now to open this bracket, I'll be having 7 times 2, 14 x raised to power 6. So that's particular basic rule of standard derivative applies to this. Let's go to more questions to consider. If I have something like x raised to power, if my y, being the f of x, is given as x raised to power, okay, let's take 1 over x raised to power 2. Recall from the law of indices that 1 over x raised to power 2 is taken as x raised to power minus 2. So therefore, I am differentiating my f of x can be written as x raised to power 2. So here I am differentiating my y with respect to x as I am differentiating f of x raised to power x over the x to this, which implies I am differentiating x raised to power minus 2 with respect to what? Change in x. Now in this case, following that principle, the power that I have there is what? Minus 2. So we have minus 2. Now to multiply the value, which is x raised to power minus 2, then I have minus 1 added to the power. So from there, I'll be having minus 2 to multiply x raised to power minus 1 minus 2 will give me minus 3. So I'll be having minus 2 x raised to power minus 3. And from here, that implies, or that means I'm having minus 2 over x raised to power 3. Now, that's another example there. Let's go into more examples for better understanding of this same basic rule with different or other form of expressions of y. Now, peradventure, I'm giving an expression in terms of 3 root x raised to power 4 when my y equals to this, or let's say this is the function of x being equal to 3 root x raised to power 4. This, according to the law of indices, can be written as x raised to power 4 over 3. Now, which means my f of x is x raised to power 4 over 3. X raised to power 4 over 3. So using this value now, I mean using this procedure now, I'll be having the f of x there over the x to be the power will come front to multiply x raised to power 4 over 3 and the power of what? Minus 1. Now, all that I have to solve now or focus my calculation on is the calculation of the power. Now I'll be having 4 over 3 to multiply x raised to power. This will be 4 over 3 minus 3 over 3, giving me x raised to power 1 over 3. Yeah, that's 4 minus 3, that's 1. So over the denominator are the same. So I'll be having 1 over 3. So easily I can say I have 4x 1 over 3. I mean 4x raised to power 1 over 3 all over 3. That 1 over 3 simply means the cube root. So that means 4 into cube root of x all over 3. That is the solution for that. Now let's just take one more example here because I would love us to quickly consider something under trigonometric function. The differentiation of a trigonometric function. Because in the picture that I will be attaching to the video, I'll be attaching some of the basic rules of standard derivatives, where we'll be having the differentiation of sine to be cos and the differentiation of cos to be minus sine. But in this case now, I just quickly want to bring something up. If I have something like my y being 1 over 3 cos x, 1 over 3 cos x. So in this case now, how do I do it? Or what do I do in this case? Recall that here there's no power involved. So therefore, we remember that 1 over 3 remain as the y dx is given. So the differentiation of cos, remember, will give me minus sine x. Then by the time I open out this bracket, I'll be having minus 1 over 3 sine x, as simple as that. Thank you. This is just where I want to stop us basic standard derivative is concerned. So chain rule. Here let's consider the differentiation of the exponential of an algebraic expression. Taking for example, if y equals to 2x minus 3 all raised to power 4. Let's consider our 2x minus 3 to be a value t, so that our y can be taken as t raised to power 4. So the differentiation of y, that is the dy dx, will be taken as dy dt times the t dx. What do we mean by this? Let's try to explain that explicitly. Now that means I'll be having dy dt to imply that I am taking the differentiation of y with respect to t. Differentiation of y with respect to t. So here I'll be having 4t raised to power 4 minus 1, which will give me 4t raised to power 3. And also my dt dx. So now I'm coming back into what I have in my t, where my t is what? 2x minus 3. So that will give me the differentiation of 2x will give me 2, because the power of x will be taken as 1. So 1 will come forward to multiply 2, and 2 times 1 will give me 2. Then this one will be minus 1, which will give me 0. And x raised to power 0 will give me 1. So I have 1. Minus my differentiation of a constant will give me 0, because the x assumed x here is raised to power 0. And the 0 multiplied by the 3 will give me 0. So n raised to power 0 still be 1. 1 times 0 will give me 0. Meaning the differentiation of any constant is given to be what? 0. So that's 2 minus 0, which is equally what? Equals to 2. So therefore, my dy dx taken as dy dt times dt dx is 4t raised to power 3 times 2. 4t raised to power 3 times 2. So in such case, what do we have? I will be having a full expression of what I have here, meaning 4 into 2x minus 3 all raised to power 3 times 2. So all this raised to power 3 now, I'll be having 4 into So let's go and check this. If I have square of this, that'll be 2x minus 3 into 4x squared plus or minus 2, that'll be 2 into 6x, that'll be plus 9. So from there, I'll be having the algebraic expansion here will give me 8x cubed plus this and this 18. 18 times 2 will give me 36x. Oh, sorry. Firstly, let's go with this. That'll give me 8x cubed minus 12 times 2, 24 x squared plus 9x. Then we move to minus 12x squared. This times this plus 3 times 2, 6, 6 times 6, 36x, then minus 27. So from there, I'll be having 8x raised to power 3 minus 2x squared minus 24x squared will give me minus 36x squared plus 9x squared plus 36x will give me 40, 45. That'll be 45x minus 27. So there I'll be having 8x cubed minus 36x squared plus 45x minus 27 all times 2. Now I will now have this times this give me 8 into 8x cubed minus 36x squared plus 45x minus 27. So from there, I can now have 8 times 8 to be 64x cubed. 8 times 6 will give me 48. Remember 4, 8 times 3 will be 24 plus 4, 28 x cubed x squared plus this times 5 is 40. Remember 4, 8 times 4 there is 32. 32 plus 4, 36 x. 8 times 7 is 56. Remember 5, 8 times 2 is 16 plus 5, that's 21. So this will be our final answer for that expression. That is for an example under chain rule. Now quickly, let's move to the next subtopic. Now under product rule, given that the equation of y is given to be the product of u and v, where u is equal to a particular algebraic expression and v equals to another algebraic expression. So the product of two algebraic expressions now giving us a particular algebraic equation which equals to y. Now in the case of such expression, the y dx therefore is given as v du dx plus u dv dx. Now let's take an example on this kind of expression. If I have an example given as y equals 2x minus 3 into x squared plus 4. In this case, what do? Our dy dx is taken as, let u equals 2x minus 3 and v equals x squared plus 4. So therefore, I'll be taking my v dot du dx. So in that sense, what's my v? I'll be having my v as x squared plus 4 to multiply my differentiation of 2x minus 3 dx. Then plus my u being 2x minus 3 to multiply the differentiation of x squared plus 4 with respect to what? X. That's my dv. So in this case, now I'll be having x squared plus 4 to multiply the differentiation of this, which will be giving me 2 plus 2x minus 3 to multiply the differentiation of this, which will be giving me 2x. Now, here I will now have to expand. In this case now, I will have 2 to multiply this to give me 2x squared plus 8 plus to multiply this I will have 4x squared minus 6x. Then now from here, I will have 2x squared plus 4x squared, collecting my like times, minus 6x plus 8, giving me 6x squared minus 6x plus 8 as the differentiation of that expression. That's what we, an example there under product show. Now to quotient rule. If the equation of y is given as y equals to v u over v, where our u equals to a given quadratic expression and v equals to another quadratic expression. So the differentiation of y, meaning the y dx, is given as v du dx minus u dv dx, all divided by v squared. Oh, let's take an example. If our y equals 2x minus 3, all divided by x squared plus 4. So in this case now, my u will be by 2x minus 3, and my v will be x squared plus 4. So the differentiation of these, according to what we have here, be given as my v being x squared. So therefore, my dy dx be given as my v being x squared plus 4 to multiply the differentiation of 2x minus 3 dx minus my u now, which is 2x minus 3 to multiply the differentiation of sorry there, that will not be a space enough. So my dy dx will be my v x squared plus 4 to my u, which is 2x minus 3 dx minus my u being 2x minus 3, then the v now being x squared plus 4 dx, all over x squared plus 4 all raised to power 2. So in that case now, I will now be having, from the example, x squared plus 4. If I differentiate this, I'll be having 2 minus, if I differentiate my x squared plus 4, I'll be having 2x. All of this divided by the expansion of this will give me x raised to power 4 plus 8x squared plus 16. So from there, I'll be now be having the expression or the expansion of 2x squared plus 8 minus 4x squared minus 6x over x raised to power 4 plus 8x raised to power 2 plus 16. And this will result to 2x squared plus 8 minus 4x squared plus 6x all over. Okay, we can just factorize this back to give us x squared plus 4 x squared plus 4. Then let's see this is factorizable. We have 2x squared minus 2, 4x squared. 2x squared minus 4x squared, that will give me minus 2x squared plus 6x plus 8 all over x squared plus 4 x squared plus 4. Is this factorizable? Let's check. From what we have, minus 2 and 8, that will give me minus 16. Is there is there two value so that the product can give me minus 16 and the sum can give me 16? Okay, from 16 we can have 8 and 2. So if I have plus 8 and minus 2, if I multiply them, I will have minus 16. If I add them, I will have plus 6. So let's check that. Minus 2x squared minus 8x plus 2x plus 8 all over x squared plus 4 x squared plus 4. Let's see if it is factorizable there. So from there, I'll be having something is in common there. So from there, I'll be having for the first one minus x, giving me 2x plus 8. In the other place, plus 1 into 2x plus 8 all over x squared plus 4 all squared. So from there, we're having 1 minus x into 2x plus 8 all over x squared plus 4 all squared. That will be the differentiation using potential. Thank you.